Hey guys, today I've been asked to do a little bit of a guide on Angular 2 unit testing. I feel like this is probably the best time to do it. This is kind of my day job. I'm a programmer and I've been coding right now for 7 years so far. I haven't really done much videos on it on YouTube. But I thought this is as good as time as any because a lot of people are getting to Angular 2. It's a new framework. It's very popular right now, and unit testing in particular, I know it's kind of a chore and a hassle for a lot of people. But hopefully my guide will help people out. And I know the documentation on the Angular 2 unit tests aren't that great in my opinion. So I also hope my guide can help out a lot of new folks. To get started, I'm going to show a lot of examples from the code that I've written so far at my company and show you guys exactly what I've done and what kind of issues I've encountered with Angular 2 unit tests. So yeah, just to give a overview, Angular 2 is it's kind of the new version of Angular. Now Angular 1.x was pretty popular, but Angular 2 is quite different in many ways. First of all, it uses TypeScript, which is very similar to ES6 or ECMAScript 6, but it's different in its own way. So you'll find that it's not exactly the same. And a lot of people choose these days when they're starting a new website, they're choosing a new front-end framework to use. They're usually choosing React.js. They're choosing between React.js and Angular 2. And these two are the two most popular front-end frameworks to build with at the moment. I know there's Vue.js as well, which I'm a big fan of, but Vue.js isn't as popular as either of these two at the moment. Of the two, I've had experience with both because I've worked with both. I feel that React.js is a much higher learning curve. First of all, you have markup in the JS files like JSX. Dealing with the component lifecycle, passing in props and stuff, it's a very different way of coding than the past. Well, Angular 2 is actually quite different than Angular 1. It's more similar to Angular 1, I believe, than React is to any other JS library, really. So in that sense, I think Angular 2 is actually a little bit easier to learn than React.js. So that's why one reason why I like it. Another reason is because Angular 2 comes with everything outside of the box. It comes with all the templating engine and everything outside of the box, just like Angular 1 did, right? You had this old school, back then, I would say like 4 or 5 years ago, people were using Backbone.js a lot. Backbone.js kind of required you to use other libraries to augment it. It was built on top of jQuery and underscore JS, but really it didn't really have much to it, and it's kind of what you prefer, right? Backbone.js is more lightweight, as is React.js, I would say, because React.js is kind of similar in the sense that it's purely the UI layer, the view layer, right? In order to do actual XHRs and requests to the backend, you would have to augment React.js with something like Redux or Flux on top of that. Just like with Backbone.js, which you had to augment with Marionette.js or Lodash. Handlebars.js is another one for templating, or other third-party libraries. Epoxy is another one to get the full data bindings and everything, to basically augment it. So same thing with React. So React and Backbone are kind of lightweight libraries, whereas Angular 1 and 2 have everything out of the box. So it's kind of trade-offs. It's not as flexible. It's very opinionated, but hey, you get everything out of the box, so you don't need to install many other third-party libraries. Like you really should not be using jQuery with Angular at all, right? If you're using Angular the right way, you don't need jQuery at all. So that's one benefit, I guess, of using Angular 1.x, now called AngularJS, I guess. AngularJS now refers to Angular 1, and Angular 2. Well, I just call it Angular 2, although right now technically it's Angular 4, and it will be Angular 5, I believe, in a few months, but it's been delayed. And it'll keep going up. I think Angular 6 next year. So, but well, I just call it Angular 2 because it's the new version of Angular, right? Or AngularJS usually just refers to Angular 1. So it doesn't use the MVC structure or anything. This is the new paradigm that we're going with these days. We're going to use components, right? Components is the new paradigm in front-end programming that we're doing. If you're coming from AngularJS, some things are similar, some things are different. The old AngularJS had stuff like scope.apply, and scope in general does not exist in Angular 2. But we do have equivalents, rough equivalents in Angular 2, like scope.apply, for example, in the old AngularJS would apply changes that you would apply data binding changes, right, that the view did not detect. So the scope was outside the scope, and you had to apply the changes that you got from your data bindings. So you use scope.apply. Angular 2, you have something similar called change detector ref dot detect changes. You had to import change detector ref, and you call detect changes, and it detects any changes outside of the Angular zone, and basically it makes those data bindings happen, right? Yeah, it detects the changes from from the backend. So any changes to the data from the model, I mean, would get applied when you do that. So yeah, it's some things are similar, some things are pretty different. So yeah, so right now I've been using unit tests. I've been working on unit tests at my company for a few months now, and I feel like I should be doing a guide or a walkthrough on this. Now, React.js uses Mocha for unit testing and sign-on for spies. Angular uses Jasmine, which has their own spies. So starting off, this is the current Angular 2/4 /x testing documentation right here. You can see. And this is a good starting point, but I would say that the tutorial is not that helpful because I went through the tutorial myself and I found like a lot of things just don't work. If you go here, it says, okay, so use Jasmine, and Karma is the test runner that we're using here as well. It's pretty popular as a test runner. Protractor is for end-to-end tests. I'm not going to get into that this video. I'm still working on Protractor as well, but I think that if anything, the Angular 2 end-to-end tests need an even better guide because this documentation isn't very good, but the one for running end-to-end tests on Angular 2 is even worse. So right now I'm still working on the Protractor part of it. But I think I have a pretty decent handle on unit tests. So yeah, let's do unit tests for now. Maybe in the future video I'll do end-to-end tests. But yeah, right now we're using Jasmine, and this is the setup here: isolated unit test versus testing facilities. Okay, this is a Karma test. First of all, I'm going to assume in this video that you guys have an Angular application set up. You've already installed Node, you've installed npm and stuff. So you have all the prerequisites installed. The TypeScript compiler is going to compile your TypeScript to JavaScript files. So I'm going to assume you have all that installed, and npm test is the command you need to use to run your unit test with, right? So let's take a look at a unit test first. This is my project here. I have an example. This project is for header component.ts. So this is header component. This is my Angular 2 component right here. You can say this is how you do Angular 2, by the way, if you guys haven't seen a TypeScript file before. But in this video, I'm already assuming that you've already made some Angular 2 components already. You're just looking for a way to unit test it. But basically, yeah, you have you import all your prerequisites, all your dependencies right there. You do add component. And by the way, there's a different way of testing. I'm going to go through testing a component and testing a service because they're kind of different. So first of all, we're going to go through the component, testing a component here. So I have here something called header component. Now, in this header component, I have, of course, your code is going to be quite different than mine. Could be quite different than mine, but I have, right now you can see my header.html on this other side of my screen right here. So I have this stuff called viewChild, and viewChild basically just refers to this section of the DOM right here that I've labeled. So I have another component here this is really a Bootstrap component, but we have here called app inbox modal, and we have a viewChild here that references that, and it's actually another component here. Oh, it's a component that uses a Bootstrap modal, my bad. But yeah, it's another component. We reference it here with viewChild, and yep, this is our TypeScript file here. We have to test, for unit tests, we want to be able to test all the functions to make sure they're working correctly. Now, the difference between end-to-end tests and unit tests is that for end-to-end tests or integration testing, we're testing the UI, we're testing aspects of the UI, and going through the application as if you're an actual user, right, and testing a whole bunch of different scenarios. Now, with unit tests, we're not doing any of those things. We're not pretending that we're the average user going through the application. Right. For integration testing, end-to-end tests, you have to go through Firefox, Chrome, Safari, IE, probably MS Edge as well. But you're just pretending to be a user and automating it and going through the website. But for unit tests, we don't care about any of that UI stuff. For unit tests, we just pretend that this piece of code just exists standalone, and there is no website associated with it. We just pretend that, right? We just want to test the function by itself, right? As if this is just a standalone piece of code, and we don't have any website or any application associated with this. We just want to test the functions, and each test is going to be standalone. So go back to header component.spec, and every Angular component has to have a .spec if you want it to be unit tested. So you have .spec here. Now there's a few things I want to note here. This is my spec file for my header component that you just saw. One thing is we imported custom element schema and no error schema, and I always do this, and the reason I do this is because we use a lot of like custom tags in our HTML, in our Angular 2 templates, and this just allows us to avoid any of the errors. Else we're going to get a ton of errors if we test it. So I can show you guys right here. If I comment out the import here, and of course I also have to comment out the schemas as well, and I try to run the unit test, you'll see what kind of error that we get here. So let's do npm test. This will start up the Karma, and Karma Runner will start up and launch us into a Chrome instance. And in this Chrome instance, it basically goes through all the unit tests. And if my intuitions are correct, we should be able to get an error here because the no custom element schema has been commented out. So let's see. We can go ahead and go through all the unit tests here. Okay, Karma is starting. We're connected to Chrome. It's going through all the unit tests now. Okay, so a whole bunch of unit tests now failed. By the way, guys, this is my first guide on programming. So basically, I'm going to go through the code and I'm going to show you guys what would happen if you do this and do that, and tell you guys what I've learned from basically coding these unit tests. Okay, so this is the kind of stuff that you'll find if you comment out this custom element schema stuff. So it'll give you these kind of errors. Okay, template parse errors. And it says, please add custom element schema, no error schema. Okay, so you get a lot of these complaints about the schema if you don't have that. So all my tests basically fail without it. That's why I have to import this custom element schema, no error schema. And then in the bottom here, in the testbed.configure testing module, you'll have to add it as well. But I'll go over more of that later as well. But anyways, my WebStorm automatically saves, so we're going to reload the page, and Karma is going to run again. This time, every one of my unit tests should pass because we don't have the schema errors anymore. I've now put it back in. Okay, so everything passes, right? So that's why you need the custom element schema, no error schema, because we have a lot of custom HTML tag elements, I believe, in our HTML, so I need to have that. Now this stuff, I'll go over more deeply, each of these, what they do. You need to have component fixture and test bed. Those are things you have to have. And then async, fake insync, and tick are used for a specific kind of unit tests, and I'll go over them later. This is our header component. Now our header component uses some services. It actually uses util service, session service, site service, you see in here, to import those as well. So we import our site service, session service, and then translate module. We have another module that we're using called translate module, so we have to import as well. And this is manifested as a pipe in our HTML code, in our template. It's manifested as a pipe, but we're importing the module from there. Then util services we're also using in our header component right here. These are all services that we're using. So basically, for every service you're injecting into your constructor right here, you have to import it in your unit test at the beginning here. Then we have to import an observable here, and then here is the describe. The describe is the beginning of our unit test, and we're describing the header component. Generally, what I like to do is to have a big describe. You can nest describes, by the way. So I have a parent describe here describing the header component, and I have child describes that describe every function here, right? You can see that every function here has its own describe block. And inside each describe block, I have an it block, right? You see these its right here are testing scenarios. So every describe is testing a function. Every it should be testing a scenario of that function. It should be testing a different case, a use case, right? Now, I said this is not the same as end-to-end testing. End-to-end testing, you have a whole variety of testing cases. But in this time, you want to test the different conditional branches and stuff in each it. And that's all part of the function. All right, so going back to the beginning again. Since TypeScript is very, very similar to ES6, I'm not going to say it is ES6 because it's not, but it's very, very similar. So therefore, you have ES6 syntax like let. So you have let component. This is a header component. And of course, with TypeScript, we always have to define the type, right? So component is going to be of type header component. Fixture is going to be of type component fixture. Those are things you have to have. These two, you have to declare them right here. And then, and by the way, guys, yeah, let means we're going to possibly reassign it later. Otherwise, we should be using const here. But we're using let because we're probably going to be reassigning it in the tests. And we have other lets here for the stubs here. Now, I originally wanted to use mock classes in Angular 2. So I looked at the documentation here and I looked at mock classes, but it just never worked for me. I always run into an error so I tried using mock classes and I always ran into some error with override component and I wasn't able to actually get mock classes working. Let me see if I can find the section of the documentation here. Can we mock? Okay, we don't have. I swear there was a section on mock classes here. Okay. Yeah, okay, override component, here we go. Yeah, I had an issue with override component when I was using mock classes. So basically in Angular 2, I can't find the section right now, but that just shows you how bad this documentation is. I can't really find anything very well, but there was a section about mock classes that you can override your entire class with just a fake class, just for unit testing, right? And that would give you total control over all the functions of your code. Because some functions in your component may be very, very difficult to unit test. If you have anything that's operating on the DOM, for example, if you have anything that has it's checking for a timeout or it's clicking on some button and it's checking for something, a lot of DOM stuff, right? Okay, mouse out interval, this is one example, right? Clear interval, clear more button timeout. It's doing a lot of UI stuff here. It's doing a lot of like DOM manipulation, and you have click events, you have mouse events, you have timer events. It's kind of difficult to unit test this stuff. So it would be nice to just have a custom class, a mock class, to fake all these functions out and make it work with unit tests better. But unfortunately, I can't get that to work. I always run into some error with override component. So yeah, I have to use stubs here, and stubs are how I'm using these, how I get these services working. That's another thing you can use mock classes for, is if you have something in your component that's doing service calls or XHR calls, then if you use a mock class, you can easily override it with your own methods that won't actually go out to an actual backend somewhere, okay? Because we don't want our unit tests to actually be making network calls. That's very, very bad. Because we're probably running these unit tests. For these unit tests, every time you check in the code, right, you should be running a PR verify, and you should be running all your unit tests every time you check in or commit to the code, right? Every time you commit to the code base to GitHub or check in the code, you should be running the unit test, and we don't want it to strain the network by making unnecessary network calls. So we want to override those in our mock class. However, can't do that. I'm running into errors, so we're just going to be using stubs instead. And this is how you use stubs. Stubs are not as versatile as mock classes are. Mock classes allow us to fully override everything, but a stub allows us to override just a few methods, right? Just the one or two methods that you're using. So in this case, I've mocked out util service stub, site service stub, session service. So these are all the services I'm using in my header component, and I'm overriding them with a stub instead. You can see that for all these methods, for example, util service stub get page name, right? This is used in my ng on init. So on init of this component, it's going to call util service.get page name. Now I actually don't want it to call my util service. I don't want it to use the actual service. I want it instead to use my get page name stub instead. And why do I want to do that? It's because if I call the actual service, it's going to make a lot of unnecessary things happen, right? It might be making a network call, which I don't want to happen. So I want to replace it with this stub function right here. That's basically a fake function. So I have here get page name. So this is what I want to test, right? I'm testing my ng on init, but we see that on init we're calling get page name from util service. So we're going to make a stub for util service, and we're going to make get page name a fake function for it, and we're going to call jasmine.createSpy. So jasmine.createSpy allows us to spy on this function. Now in other frameworks you'd be using sign-on if you don't have Jasmine. Sign-on basically does the same thing. It's a spying framework, so you can it's a library for spies, so you can use it for spies and stuff like that. But for Jasmine comes with its own built-in spies, so we don't need sign-on. So jasmine.createSpy get page name here. This is going to give us a so spies are basically a way of letting us know whether or not the method has been called and what parameters it's been called with. So we create a spy with the same name, and we call a fake function here. Right now in my fake function, I return nothing. And that's exactly what I want, because I don't want to actually call the function. I just want to test to see if it is calling a function on util service stub called get page name. That's all I'm testing here. So site service stub, same thing. Create a spy, you call a fake. In this case, it's a promise, so I resolve it with true. If we look at the actual implementation here of getFormID, okay, we can see that getFormID returns a promise. So this is one of the things, and it's doing a network call here. So this is one of the things you would want to stub out or mock out, is something like this. In an actual unit test, you don't want it to go do any kind of network call, like a get call here. You don't want it to do that, right? So in this case, it returns a promise. So you want to stub that out. So in our header spec, we create a spy and we stub it out with a promise.resolve true. This is a fake function that returns just a resolved promise, and that's it. We're not actually doing anything. We're not making any network calls or anything. This one, get user info. Let's take a look at that one. Get user info. So this one actually returns this is a service that returns this object, right? Returns an object. So here we just return a fake object here because we want to test something about this object, right? So in this function we're calling get user info, and we're going to test the results of this object. So we're just going to return a fake object here with some variable names, some mocked out names here. This is just some static strings right here. All right, and the other stuff is pretty much all mocked out here, as you would expect. Open modal listener, this one is we had to stub out as well, since this is the property of this bootstrap function here. So we're opening a modal here. There's an open modal listener, which is called on this bootstrap component, and we return observable of true. And observable would means that, oh, this thing changes, right? This thing would change, and in the actual bootstrap function, it would listen to the observable. So here we're kind of mocking out the observable to always return true. And here we're using, so in header, in this component right here, in the config, we're using some stuff from window. Now, the window is a global object, right? So here we can just mock out the stuff here, otherwise it's going to fail. If I don't have this window stuff set, it's going to look for it and it's going to say undefined. It's going to say can't find undefined, can't call something of undefined, right? So I have to mock it out here with putting this stuff on window, which we can do at any time because window is always a global object, and we can mock it out like that. Okay, so now in order to set up the unit test, we had to do testbed.configure testing module. This is something you have to do for all component unit tests. And we had to declare this declarations here. We have to declare what component we're testing. In this case, it's header component that we defined all the way. Oh, this is the actual component, but we defined that right here, right? Let component, header component. Now we declare that, and then we import translate module for root. Now here's where you would import any of the third-party stuff, right? This translate module is a third-party thing, so it's a third-party library. We would import that, and Bootstrap, if you're using any Bootstrap libraries here, like a dropdown, for example, like a BS dropdown, you would import the module for root here as well. Then we have providers. These providers are all stubbed out. I've already gone through them. So we're going to provide what this unit test is going to do is going to look for these services, but we're actually going to use the stubs instead. So we want to provide all these services, but we're actually going to use the stubs. So that's why we have use value here. Provide the actual service, but use the stub value. And then the schemas I've already gone through. We have to use the schemas, otherwise we get tons of errors. And then we do compile components here. All right, and then in the before each, this is something you could put on at the beginning of a bunch of describes or not. But this is before each test. This is a function that will run before each test. So we have create component right here. We have fixture. So fixture is going to be component fixture of type header component. So we're going to do testbed.create component header component. Always do that at the beginning. So this is before each is the functions you want to run before each test. So we always have to create a header component before each test, and we always set the fixture component instance to this variable component here, which is of type header component. And then we're going to set some hard-coded stuff, because in our particular HTML, and your HTML obviously will vary, but in our HTML we use some stuff from the nav, right? So we're going to hard code some stuff in the nav because that's what we're displaying on the page. And if we don't do this, it's going to complain the HTML is not going to render at all. So we basically had to hard code some stuff here just so that the template is going to render. Now you guys might be confused, but unit tests, when we're actually running the unit test, it actually does compile the template and everything. So that's why we stopped this. It's not going to go through, like I said, there's not going to be any UI stuff, or shouldn't be any UI stuff done on unit tests since it's not integration testing, but it's still going to compile the templates. So we need this to be able to define the templates here. All right, so now we go through the describes and we're testing each function here. And the first thing I usually test is the onInit function. So ng onInit, what happens when this component actually loads? And here, you know, we have a whole bunch. Actually, this should be organized a lot better because this looks pretty messy right now. But what should happen is we're just going to go through it and test exactly what happens on init here, right? All this stuff right here. So we're going to test, first of all, that it's not null. This is a very, very basic test. It's a sanity check, really. In the next one, we're going to check fixture.detect changes. What it's going to do is actually going to call. So the reason why we always have fixture.detect changes is because we want something to happen when the page loads. We want all the data bindings and stuff to be called. Basically, all the things that's going to call on ng onInit is not going to be set or called until we call fixture.detect changes. And once we do that, then all this code is going to run, and then we expect util service stub.getPageCalls.calls.count to be 1. And we can see why it's like that, because we have this line of code here, this.currentPage equals util service.getPageName, right? Once we call fixture.detect changes, it's going to actually go through and execute this part of the code, which means it's going to call our util service and it's going to call getPageName. Now, our util service, as you can see here, is actually going to use the util service stub. So we're going to go to the util service stub.getPageName, and we have a SPY here, right? Now we can use that SPY, and the SPY gives us an idea of how many calls, how many times it's been called. So that's why we can do getPageName. This is going to call the SPY right here, dot calls. This is how many times it's this is all the calls basically. It's got more information here, but we just want the count. How many times it's been called to be 1, because we call this exactly once on init. See, it's only here once, so we expect this to be only called once, and that's why we have this it test case here. And we have that for the rest of the stuff here. Get user info, site info, get form ID, because we know that this is only going to be called once. And this is exactly what you're supposed to do in a unit test, is you test each individual function, in this case ng on init, to make sure that everything is working as expected. So everything is expected to be called once, and that's why I've been expect here, and it's called once for each of these. And here we have an interesting case here. It says should call get notifications after get form ID. In this case, this is a little bit different. So spy on is Jasmine's method of spying on your component, and in this case, this method get inbox notifications. Let's go to this method right here. Okay, you see here this.site service get form ID, and then we have a then here. The then means that we're using a promise callback here. So there's a promise callback, and we have form ID. If we go to form ID, you notice it returns a promise first of all. That's why we can do a then here. Then we have promise callback, and then we have a this.get inbox notifications that only happens in the promise callback, and then only happens if it's on success, right? So okay, we're gonna look at inbox notifications, and okay, it does all the stuff here, right? But let's look at what happens here. We're gonna spy on component get inbox notifications. Now we're not going to test what actually happens in inbox notifications in this part of the code yet, because this is its own separate function, right? We're going to test that in its own describe later. Right now we're only focused on ng on init. We only want to test what's happening here, so we don't care what really happens here. We just want to know that it's been called. Okay, so go back to the spec and spy on Jasmine component get inbox notifications. This spies on this particular function in our component. Then we do fixture.detect changes, which runs through the ng on init. Then this tick thing is used always with fake async, and the fake async in the tick basically simulates this promise call here. I guess that's the simplest way I can explain it. Obviously, fake async and tick do a lot more than that, but for this case here, it fakes in a synchronous call. It fakes in a synchronous call. So in our callback of fake async, we can do a tick, and the tick basically asks it to run through the promise callback. That's what it does. It asks to run through the promise callback into this function here, and this calls get inbox notifications. And then we expect component.get inbox notifications to have been called. Now we can only do this because we've spied on this function already. If we didn't spy on this function, we cannot use this expect. So we had to spy on this function first, and then we do get inbox notifications to have been called. And this is the exact same thing as to have been called once, right? To have been called once or greater than once, right? Greater than once. So that's exactly what this function is doing here. So yeah, for example, if I didn't do this tick here, I'll show you guys exactly what would happen. If I didn't do this tick, I would fully expect this to fail, because this tick is pretty essential to getting the promise callback to actually run. So let's take a look here. What happens if I comment out the tick? Okay, so one thing failed, right? Now what it's going to say is it's probably going to say it's not been called, is what I'm expecting. Okay, so expected spy notifications to have been called, right? It never got called, and the reason is because if we don't do this tick here, it's not going to go into the promise callback. So we need this tick to go into the promise callback, and then it calls get inbox notifications, which is exactly what we expect. So we should expect this thing to pass here, which it does. Okay, so it passed, and yeah, that's a little bit of a walkthrough of fake async and tick. You basically want to use that if you have a promise callback you want to get into. Okay, next we have get logo URL. Here let's look at this function here. I'm going to test each individual function now. Okay, so this logo URL looks at the site info.logo URL right here, and it does a bunch of regex here. replaces it, etc., etc. Okay, so in here we want to set something siteinfo.logo URL, and the reason for that is because we want to hard code something. In this function, it uses this hard coded value, and we want it to be like this. That's testing exactly what the function does, right? This function looks at siteinfo.logo URL and transforms it into something else. So in this case, we have to hard code something logo URL, and we expect this kind of result. This is exactly the result after it runs through this function, I guess. It runs through the regex stuff. So that's why we have that. So yeah, we would hard code some of these things and make our own objects sometimes if we need it in the function. Yeah, because usually the stuff comes from a network call, right? And we're not doing any network calls in a unit test, so that's why we have to hard code it. Okay, build menu. Okay, so here, let's look at build menu. Okay, build menu, yeep. Okay, it gets in data, so data is the argument here. And if it's equal to -1, then this is set to false. Otherwise, you slice the nav or something. And we've already established that nav has already been hard-coded in this unit test. Right, at the beginning of this file, we've already hard-coded nav to something. So this should work. And yeah, it looks like length to be build menu count equals 3. So the reason we can do this is because we've already hard-coded our nav up here. Yeah, here. We've hard-coded our nav to be 3 items here. And the reason we do that is because it uses the nav not only in the HTML but in some of our functions. So that's why we had to do that. And that's why it's 3. So we expect the length to be 3, and we expect this length to be this because it's sliced. Now you might notice a difference of syntax here. Why is it using 2b and not 2 equal? So 2b and 2 equal, they're both used with Jasmine, but you would use 2b if the result is a simple variable. If it's a simple type, not a simple variable, sorry, a simple type. So if it's of type integer or Boolean, then I think 2b is used. You would use 2 equal if it's an object or a string. So that's usually when I use 2b versus 2 equal. So 2b used with integers or Booleans, and 2 equal to be used with more complex objects, like an object or a string. So more complex types for 2 equals. Okay, this is, yeah, so like 2b false. This is have to use with a simple type like a Boolean. And okay, this is an interesting one. More button timeout. Let's look at this. This one is kind of hard for unit testing because it does a set timeout, which is kind of a UI thing. By the way, any DOM manipulation and stuff, I don't like to unit test. You can see here, like this stuff, the query selector, native element query selector, class list and stuff. I really don't like to test this with unit tests because this is more of an end-to-end test thing. Really, you could unit test this, but I would prefer integration tests because you can actually see the visible effects of this. Because when we're adding stuff like, when we're doing DOM manipulation, what we're doing actually is affecting the UI aspect of the page. That's usually what we're doing. And it's really better to test that with an automated integration test or end-to-end test than to use a unit test for that. So that's my opinion. That's why I don't like to test any DOM manipulation or DOM stuff with a unit test. I usually like to save that for end-to-end tests. For a unit test, I like to test this functional stuff. What is the function actually doing? All right, so here look at more button timeout. We set a timeout here, and we have the timeout is set to this mouse out interval time, and it's setting something to false. And then we call cdref here, which is something else. So what we do here, we spy on window. So set timeout is a function of window, so we spy on it. And we do component. We actually call the function itself. Usually that's what we do. In these describe tests, we're testing the function standalone as if it exists by itself in a vacuum. So we just call the function, and then we expect a result here. So we expect the Windows set timeout to be called with this mouse interval time here, with Jasmine.any. So we have mouse interval time 300 set as a default in header component. So I guess more menu config and everything comes from here. Yeah, so it's already set in the init. So that's why this will work. And that's how you do that's how you test a set timeout. Is you spy on the window and then you expect a window.set timeout with to be called with. And then this stuff should try my true. Yeah, so this is something similar, set timeout called with Jasmine, and then with 200, I guess is the argument call here. This 2 have been called with tests for all the arguments that you've been calling with, all the parameters that's been passed in. So you can see that here. And I think the rest is stuff already gone over basically. So okay, clear timeout. Let's look at how it's doing this. If notification timer, you call clear timeout. Oh, okay. Whoops. It's actually it is part of ES6. So yeah, we're just gonna spy on window, and we expect okay, get an inbox notification. This is what we're testing here. Yeah, clear timeout is a function of ES6. So it checks for this variable if it exists, and then you clear timeout. You call clear timeout. Okay, so we set this to true. We hard code it because that's what we want to do here just for this function. We call this function, and then we expect this to be called because it's true in the code. So yeah, that's it for header component spec. I can go over a more complicated component. This is advanced search modal. And this one's a little bit more complicated. Let me pull up the file here. Yep, this is the HTML, and this is the modal component right here. And okay, so this is advanced search modal component. We import all this stuff. Now we have a lot of pipes in this function as well as a modal from Bootstrap. So this is how you test a component that's using a Bootstrap component as well. We're using NGX Bootstrap in this case. I know there's another Bootstrap library. It's NG Bootstrap, I believe. Yeah, there's NG Bootstrap, NG2 Bootstrap, and there's NGX Bootstrap. So they're actually different libraries. Yeah, so this one's from third party, translate module, modal modules from a third party. This is from Bootstrap, so we import it here. These are all the services we're using in our advanced search modal. These are pipes that we're using. We also had to import those pipes as well. Whatever pipes, Angular 2 pipes you're using in your HTML or template, then you have to import it as well. Now this is something we have to do is import some data here. And this data is used for mocks. We're testing mocks. And you know, in our header component, we had a lot of, in our header component spec we just went through, we hard-coded a lot of stuff. Like we did component.nav, right? But for more complicated components, we can't possibly hard-code all of that because there's just too many fields. So in that case, we actually take a mock-up of the actual JSON response from our server, and we save it inside a JSON file, and then we import it like this into a mock variable. So that's what it's doing here. Now, this is what I mean when I say TypeScript isn't exactly like ES6. So ES6, if this was native ES6, this would actually let you import stuff from the mock data as straight JSON, right? You would just import something as something from this JSON file, and it would just work. But TypeScript doesn't let you do that. TypeScript will actually give you an error if you try to do that. So if you go to, that's why we have to use this here. We kind of have to use kind of a hacky thing. So we had to make a TypeScript file here. In this TypeScript file, we export everything from this. We export these things from these other TypeScript files in the same folder, and these other TypeScript files contain the mock data. So here we have export const ideas, and this is our mock data from the server right here. And we export it, and then we have this in a bunch of files, and then we export all of it from all these files into a single file called mock data. and then we import everything as site data from, or site data, or whatever data you have, whatever you want to call it, from mock data. And that's how we get it to work with TypeScript. In native ES6, you could do something like import star as JSON data from blah 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 blah, right? Sample.json, and this would just work. But yeah, in TypeScript, everything has to be defined as a module, which means you can't really do this. But in native ES6, you can. So you can't import directly from JSON, but you have to make a TypeScript file that imports from another TypeScript file, which contains all the data that's been copied from a JSON. So it's kind of hacky, but that's what we have to do. Yeah, so this is an actual JSON. It's an object with data contained from the actual JSON response file. So that's what we have to do it. And yeah, we use this as mocks. So we do this, we call mocks, and then the mocks basically link to the data from the template, the data from the TypeScript files that we defined in the mock data here. So in this case, .template would be just all this stuff. And then, yeah, this would just be whatever we exported here, export const, some variable name, and then you just, that's your mock here. It's going to be your mock. So we use this mock when we have a lot of data, we have a big object with a lot of fields that we need to mock out, and we can't possibly hard code all of it. Well, we could, but it's just not going to be efficient. So yeah, we just import it like this here, but it's kind of hacky. All right, so all this stuff is the same. We stub out a lot of stuff here. We stub out, we stub out, we stub out, and in some cases we return the mock here. Return the mock because that's exactly what the actual call would give us. So in this case, get user info would actually return this giant ball of JSON data, right? In the actual network call, it would return us a bunch of JSON data in a JSON string. But here we're just returning the mock, which contains all the JSON data in an object. So that's basically the same, but it doesn't have to make the network call. This is the same as just giving a hard-coded response. So don't have to make the network call here. This one is the same thing, but in a promise resolve function. So this one, I guess, was not in a promise return, and this one we do have to mock out a promise return. So that's a promise callback, returns that. Here, so if you have any Bootstrap or third-party libraries, you have to do the module.forRoot and then import it like this. Otherwise, it's going to fail. I'll show you an example of what happens if you don't have this. So if you have a third-party library, you don't explicitly put it down here in the imports, you're going to get a huge error here. So here's what would happen. I've commented it out, and you can see what kind of error you would get if you don't explicitly import stuff. Okay, so if you have a third-party library like Bootstrap or Translate Pipe, okay, so it's going to say something here like template parse error, no directive set to BS modal, pipe translate cannot be found. And this is exactly what I expect because, okay, pipe translate, this is a third-party translate pipe, and Bootstrap modal, right? This is stuff we're using in the template, but we have to import it, else it's going to give us errors like this. So if you guys ever get these kind of errors, you have to import it. So that's why we need that there, and you need to do this module.forRoot. And the rest are the same. Provide schemas. We hard code some filters here, something on our component because a lot of our functions or a template uses it. So we hard code that stuff. So yeah, for these small objects, we can hard code them. But if it's a really large object and we need all the data, then we need to get it from a mock data file. So that's generally the rule I use. Let's see, everything I think I've already gone through in the header component spec. Let's see. To be, okay, 2 equal. This is an example of 2 equal. I usually use 2 equal with strings and objects, right? 2b is usually used with simple types like booleans. So in this case, this one is show advanced options, this function is going to return a Boolean, so we use to be. This one, this variable is going to be a string, so we use to equal. This variable is going to be a Boolean, so I have that. And oh yeah, I mean this is a Boolean too. Yeah, this variable is going to be a Boolean, so we use to be. This variable is going to be a string, we use to equal, and this variable is going to be an object, so we use to equal as well here. So that's what we use for Jasmine syntax for expect. I think everything else I've already gone through pretty much. Sometimes you have something like this where you have an we explicitly hard code the option types here, but you don't have to. I mean, this one you could just put into a variable somewhere again, or another mock variable, and you can just expect it to equal a mock instead. I think in this one I didn't make a mock variable for it because it was just 2 lines, it's just 2 fields. But if this was like 5 fields or something, I would definitely make my own mock variable and just set it. I would just expect that to equal the mock variable instead. What about this stuff here? Dates. I see. Okay. So for anything using dates, that's checking on dates in your code, I just put in like new date here. If you look at the actual function here, okay, it looks for a date. So in our actual function, it looks for a date here because it's a date picker thing. So here I just instantiate it to a new date. Because date's its own type of object, right? So you can't really mock that up well. We just have to make a new one. Yeah. And that's to equal empty string. Okay. So I think everything else in this I've already gone through in the header component spec. Nothing too different here. Yeah. You basically all the it cases just test a specific usage scenario, and inside this use case scenario, usually hard code something to make the function work, and then call the function itself, and then you expect it, right? This is another fake async, which means it's doing another type of promise call inside of it. User type ahead handler. So this is a type ahead call. In this case, we do call user services, then we call a function on it, then we have a promise callback. We want to get inside this promise callback, so that's why we have a fake async. We have a tick call here, and then it'll go into this promise callback. And in this case, we actually test what arguments it's been called with. So in this key press handler one, we have an event and a type here. Now in this one, I passed in a key code 13, which is enter key, and hard coded string here, so that's what it's expecting here. And then I just test to see if, oh, this function, I don't actually test this function because that's another test case, right? That's another describe call, another unit test. But in this unit test, we're only testing the key press handler. So we're only going to test if this key code was 13. Of course it's 13, I hard coded it. But I wanted to test if it actually called this submit search with this type here, which it does, right? So I hard code in this argument that's passed in, and then we just double check to make sure that's been called with that. And I know this seems kind of stupid, like, oh, obviously it's been called with that because you hard coded it. Well, yeah, but you want a sanity check, right? A lot of unit tests, it may seem like it's really obvious, but you still want to test it because you never know when someone changes the code. And this is the whole point of unit tests, is you want your code to be robust. You want your application to be robust. And you never know when sometime later on you're refactoring code and you're getting rid of a lot of technical debt, let's say. You're refactoring a lot of code and something somewhere breaks. Your unit test will break, even for something simple like this. For example, what if I took this out? I'm refactoring and oh look, I accidentally took that out. This code would fail, right? Or if I changed the type of this to be something else, or I did something else here, right? This code would actually, this unit test would actually fail, and that's exactly what I expect, right? That's exactly what a unit test is supposed to do. It's supposed to catch things that you would not catch normally. And even for these simple sanity checks, it's really important because you just never know, right? Sometimes someone's refactoring a piece of code and they change something somewhere else, and then the unit test fails, and If a unit test doesn't fail, if you didn't have a unit test for it, then your code would be broken and you don't know it, right? But if you have a unit test and it catches the failure, then you have actually succeeded in your unit test objectives. So that's a good thing. You want your unit test to fail because that means it's working. All right. Yep. So stuff here I pretty much just gone over. Yep. Set communities to mock. So I set this variable to be a mock object, and I call this function here, which loops through this mock object, and yeah, I just expect one of these objects not to be selected and stuff. So okay. Some things I didn't really go too in depth about is the kind of errors you would get if you did the wrong kind of expectations. So for example, this is the onInit function I went over again. And okay, so let's take a look. What happens if you do another kind of expectation here? So like this one says get page name calls count to be 1 from util service stub, right? And this one expects session service to call get user info exactly once, get site info calls to be exactly once. But what if you change that to 2? This is the kind of error you would expect to see. We would expect this to fail because in the onInit function, we only actually call get page name once, right? If we did call it twice, then it would pass. So here we have a failing unit test now. You can see exactly what the error is going to be. Okay, so the error said expected 1 to be 2, right? So that means the actual number of times it was called, which is here, to be the number of expected times it was called, right? We can actually confirm this right here. We can call this again right here by quickly pasting this once more, and you can see, oh, of course we are calling it twice now, right? So this should of course pass now. So let's just take a look, confirm that that is indeed the case. Okay, so yeah, it passed. So just to give you an idea exactly, a little bit more in-depth look at how exactly these expectations work. So now we call it twice, and the expectation to be 2 is now correct, but now we actually want to change it back to 1 because that's what it was before. Okay, so let's look at another one that we can change here. Okay, so this one is, actually this should be a 2 equal because of the string here. Okay, so this one, 2 equal this string, right? This get logo URL is this regex expression here. So what if we change this to be something different? You can see exactly the expectation here, what the unit test will say if it fails on a string. And I think this one will tell us exactly what the string actually is. So you can pay attention here. One's going to fail. Okay, one's going to fail, and okay, it's going to tell you exactly what string is expecting here, because this is the actual output of get logo URL. So get logo URL, the Karma test runner actually gives us the actual, or Jasmine actually gives us the actual output of that function, and this is the string we were expecting. So, I mean, this is very, very common when I'm doing things. Sometimes I don't really know what this is going to be like until I actually run through the function. This might be a very, very complicated input, and I don't know what the output is exactly going to be like. So in order to get the output, I just run a unit test failing on purpose. And the reason why I want to fail on purpose is because I wanted it to tell me exactly what the output is going to be. That way I can just copy and paste it here with this, and this is exactly what the output is going to be, right? So a lot of times when I don't actually know where the output's really complicated, something like this, the output's really complicated, I don't really know what it's going to be. I make it fail on purpose just so that I can see what it's exactly going to be. So that's another way I have of getting the proper string or object. Objects are more complicated, so you'll see something a little bit bigger if it's an object. Let's see, another one we can do here. This one is pretty easy. It's just going to say, if you change this to something different, like true, for example, but it's actually false, it's just going to say expected false to be true, right? That's what it's going to say. Let's find a more complicated one where it's expecting to equal an object. So let's go back. Idea component spec. Okay. So let's go down here to be false to call true. Okay, so let's look at this one here. Get saved searches, and then this one, this line 210, line 210 right here is expecting this to be equal to this mock right here. And this mock is something really, it's a big object, right? With a bunch of keys and stuff. So what if we actually expect something different? Let's just say this is going to be another test object, right? It's going to be something with test true, or I'm just making this up, by the way. I'm making some stuff up. Made up value. Who cares, right? This is an object that's not going to be the save search mock, and I'm just going to show you guys what happens exactly when the object is not equal. So this one will give you a more complicated error right here, and it's going to give an error. It's going to tell us exactly what it's expecting, but it's a very complicated thing it's expecting, right? So we get one failure here, which is totally expected. So we just change the output or the expectation, and let's see what it's expecting here. Okay, so this one, you see, this is a very complicated one, because this object here that actually returns from get saved searches, since get saved searches returns us this mock, basically all this is that mock, right? And it's this big ass long object. It's this big ass long object right here. Expected this mock thing to equal object, and this is what we put in here. Test true, made up value. Who cares, right? Yeah. So this is another way you can get exactly. It's going to be a little bit harder to know exactly what this is. But what I would do is copy and paste this. If this looks a little bit hard to read, I would copy and paste this and put it into a JSON formatter and beautify it. Because I know this is all one line and stuff, it looks kind of ugly, but you can just use the JSON formatter to beautify it, and then you know exactly what kind of object you're expecting. Because I know a lot of functions return some pretty complicated objects, and for unit tests, it's going to be hard to mock out these objects. Yeah, I would actually just make it fail on purpose. This expectation here, just copy this whole line right here, beautify it, and then just paste it inside, or create a mock for it. Actually, if it's a big object, I would create a constant variable for it, and then call them, assign it to a mock, and put that into the expectation. So yeah, that's showed you guys exactly what I was expecting here. Where was it? Get save search. Here we go. So let's just revert this back to save searches mock. There we go. And now it should work again. But yeah, that's just some examples of how I would do the expectations and exactly what kind of errors you would get if the expectations were not correct. And it's all a trial and error thing, I think, too. A lot of things are trial and error, so yeah, you learn on the go. So guys, if you keep doing these unit tests, you're just going to get better and better, because a lot of things are learned from mistakes, right? What is it they say? They say that failure is the mother of success, and mistakes are the portals of discovery. So every time you make a mistake, you're just learn from it, and well, I wouldn't say mistake in this case. I would say learn as you go along, and every time you get the wrong kind of expectation or some kind of weird error and stuff, you can learn from that, and next time you know exactly what the solution or the fix is. So yeah, guys, I guess that's it for looking through the expectations. So okay, let's move on to the next part. I'm going to go into services next. All right, so now let's look at service unit tests, because service unit tests are a little bit different from component unit tests in Angular 2. So I pulled up one of my services here. It's called page service. Very simple one. It only has two functions. Actually, one of them is not even being used. But yeah, basically one function here. It uses one service, which is util service inside the service. And this is my unit test here, page service spec. Now this one is a little bit different from component unit tests, I import different things. So the things that are different are these ones are the same from component unit tests. So mock backend and mock connection you need to import from Angular HTTP testing. And you also need to import HTTP module, XHR backend, response headers, and headers from Angular HTTP. And actually not necessarily headers. I think I just have headers because I use custom headers inside this function here. But you definitely need HTTP module, XHR backend, response, and response options. And this is because services usually deal with networking, and you're making a network call, you're making an XHR call, so that's why you need to import these ones. And of course, you need to import the service itself as well as one of the services that's being used inside the service, which in this case is util service. You also have to import the mock data as well, because for most service network calls, you're going out to a backend, right? And you're getting some kind of response, in this case, JSON response. So as already said, for the other component unit tests, for Angular 2, for TypeScript, you can't actually import JSON directly. So I have to make this mock data TypeScript module that combines objects from all these other responses basically. And once I get the JSON response from the server, I export it as a const and as an object. And this is basically the JSON response I got from the server exported as an object. And I just combine it all inside this mock data. And then I export everything and I import it as data. And that's how you can do it in TypeScript, because you can't import JSON directly, unfortunately. Maybe in an update sometime. But yeah, that's how I get my mock beta. And this is the exact response that would return from one of the calls here that you make in your service. So in the before each, you have to make an async wrapper now, because every service call is going to be async. It's an XHR request, so you got to wrap this in an async. And inside this async in the before each, I have the service stub set up right here. All this is pretty much the same, except now you're going to provide XHR backend, but use mock backend instead. And the reason for that is because, so inside a service unit test, you're actually going to use mock backends to mock up the responses. So, but you had to still have to provide an XHR backend, because the XHR backend is what the service class is going to see. But instead of actually getting to an actual server, you're actually going to a mock backend instead. I hope that makes sense. So in this subscribe call here, we only have one function to test. It's a pretty simple one, I guess. But you can see there's a lot going on here. First of all, we have to inject these as dependencies. So I inject page service, the actual service we're testing, as well as XHR backend, which is what it's expecting. And then we're going to have it be the actual page service, of course, but for the backend, for XHR backend, we're actually going to use mock backend instead. So the service is going to see the backend as an XHR backend, but we're actually using a mock backend, and we're going to respond. We're going to respond with the mock data here, mock response.data, which in our case should be. Actually, let's look inside of here. I usually put inside a subfolder, but here's what the data is going to be. This is all taken from a JSON, and I export it as data. So I import it, mock data, so I import it directly as an object, and that's what we're going to respond with. And we have new headers here. I'm going to stringify this data, and we're going to do a subscribe here. We're going to do mock backend.connections.subscribe. That's how you do it. And do connection, mock connection. So this is just something you have to do. And you do connection.mock respond. And from mock respond, you return with new response option, status 200, which means it's an OK with the custom headers. And that's because in my actual function call here, getPagePromise, it does return json.parse response.headers.getData. So this one might be a little bit different from some of your responses, but that's why I have to do this data json.stringify mock page data here, this new headers thing. If you just have return response.json here, then you might not need this. But in this case, I'm doing response.headers.getData, which is why I need this stringify here in this custom headers. But yeah, now, so this is different notice that in this async call, everything has to be wrapped in this async call, by the way. For service tests in this it case scenario, we always have to wrap in an async call. This is different than fake async. So I already gone through fake async in the component unit tests with the tick and everything. Fake async is not an actual async. It's basically if you're going through a promise callback, you want to execute the promise callback, then you use fake async and you use the tick. This is an actual async call, and it's actually going to try to go through the backend, except instead of accessing the backend, it's going to go through a mock backend instead. The mock backend is going to respond with our mock data. So the difference is that this is actually making an async call, but it's making an async call to a mock backend instead. So we're still good. We're not going to make a response. We're not going to hit our actual servers and stuff, which is a good thing. But yeah, it's going to respond. Our mock backend is going to respond with our mock page data, and then we have a promise call. This is the promise call, right? So we're going to need a .then here, and we expect. So notice that in this function, it calls util service get page name. So it calls one of my services and it calls this. So that's why I have the service stub here, and it's the same thing as in the component. Expect calls.count to be 1. Have a Jasmine spy here and a call a fake, and that's all expected. Now this stuff response dot the variable name here. We all do dot equal or dot to be depending on whether the type is primitive or complex. And we look at, if you look at the actual data here, you see we can response tab level to be tab level. I actually don't do any hard coding of anything here. It's just expecting the response to be equal to the mock data response, which is what we expect here. We're expecting this mock backend to return us the mock data, and the actual response here from this promise is going to be that mock data. So we're just doing all the expectations here. So I hope that makes sense. That's usually what it takes for a service unit test. Is you do this mock backend connection stuff, you do a mock respond, and then do an assertion on the mock data. It's usually what I do. I think I have a little bit more complicated one here for ideas service. Let's take a look at this one. Okay, this one's a little bit more complicated. What I want to go through with this one is, okay, this one does the same thing, mock respond and stuff, except you're asserting on certain types of scenarios. This one says like certain error messages and messages that you get back. So this one is a mock error. So you can do a mock error as well with a new error, pass in some error message, and whatever you have in your exception handler here. So in this one, promise calls, we all have exception handlers. Whatever's in your exception handler, you can expect the error message, and that's how you can do it. You do .then error expect error message to contain error message, and you do a c.mock error here when you do the subscribe. C mock connection. So yeah, it's basically mock connection .mock error. Then you do the actual call, and then in the .then you do the expectation. So yeah, otherwise it's basically service calls are like that. You always wrap it with an async because you're always going out. You're making an async function call, except it's going out to an actual mock backend this time, and you're just getting a mock response back instead. So I think that's basically it. Yeah, and then you're just asserting on the mock response. So that's how I test services and stuff. Using mock response. So I hope that helps you guys. If you're doing Angular unit tests, I've already gone through 2 examples of a component and then 2 examples of a service as well. So I hope that helps. Yeah, mostly for components. Yeah, just go through what I went through and see if that helps you guys. It really depends on your component, of course, and your HTML and your template and how you structured it. And of course, for services, it also depends as well. I'm just going for the most common scenarios you would use for services. I'm just assuming that for your service, you're doing a lot of service calls and promises and stuff because that's the norm. And then for components, I'm expecting things to be like the ng on init, ng on changes, some UI stuff right here, some DOM stuff that I don't really test that much, but yeah, like button timeouts, key press handlers, some toggles here. I mean, this is basically what Angular components contain anyways, is stuff like this. And testing service calls using stubs, testing for stuff on the window or other variables on the component, config objects passed in and stuff. Yeah. Oh, at input as well. I think this is one of the ones we had to actually mock out because this was an at input. So this wasn't a variable passed in from the parent. So this one we had to actually mock out. The view child here is all from the template, but hopefully you don't have to interact with this one much. And in case you guys are using third-party libraries, make sure that you use import in your testing module as well in that setup. So yeah, that's about it. That's Angular 2 unit tests. Just a brief overview of what you can expect. And I hope that helps because the Angular documentation is really, I would say, lackluster. And it's really hard to find stuff here. Of course, it's a good starting place, but yeah, it's not very good. I think they have a Plunker link somewhere here. If you go to the Plunker link, it does have basically all the unit tests, which is really helpful, but you'd have to find it somewhere here, and this is really hard to find anything in this spot, in this page actually. So yeah, and hopefully I'll do another one on end-to-end/protractor testing once I get around to that. And yeah, that's it. Another thing is yeah, the Karma test right here. So you connect it. If you ever want to debug your unit test, you can actually go into debug mode and load the debug runner right here. And in here, if you ever have an issue that you think is not right, or you want to see exactly how it's going into your code, the unit test actually runs the component, by the way. So you'll actually go into your component and call those functions. So you can just go into your sources here and you can load it. Of course, it's going to depend how you packaged your JS files here. But in my case, it's something like main.bundle here. This is all packaged with Webpack. So if you guys package it with Webpack, it's going to be some kind of bundle here. But you just search for, yeah, here's some unit tests, some describe functions. You can search it here. You can actually go inside here and see what it's doing and actually step through each of the functions here, right? And if the expectation is a little bit off than what you expect it to be and you don't know why, then you can actually debug it here, which is really nice. So yeah, this is debug runner. One thing is it won't actually refresh itself, so you have to manually refresh it. So the non-debug Karma automatically refreshes itself. What you might find useful is to generate the code coverage output of the unit tests. And how you do that is by doing ng test --code -coverage, and this will run the Karma runner along with generating an output file for the code coverage. And it's going to go through right here and generate all the files and stuff, and it's building up the modules right now. But I'm going to show you guys the output, and the code coverage output is actually really useful. It tells you exactly what parts of the code you have not covered with your unit tests, and I find it pretty useful. So yeah, this is going to run Karma, and it's going to generate the file and stuff. So actually I can show you guys the output right here. I already generated it. So this is going to be the output, and it's really useful. It's actually, you just open it up with coverage/index.html, whatever part of your project you're in, and you can see all your files here, all the components and stuff in your directory, in your project directory, and it show you exactly how much percentage of your statements of your code and your branches and functions and lines that you've covered with your unit tests. So statements is just lines, branches is like conditionals in your code, functions are functions, and then lines are lines, of course. So you can see exactly how much percentage. We haven't been doing too well on branches, but I think for statements we try to be over 80%, although so far as you can see, that's not really, like this one is really bad. That's just because we're planning to replace this one. But yeah, some are pretty good. Let's see, so the header I was just going through, this is a header file I just went through. You can see it says 65% branches, 76% of functions covered, 80% of lines, and 82% of statements. And you can see exactly what's not being covered here. Like this one is not being covered. this condition has not been met by any unit test. So you would make a unit test that actually goes into this condition right here. Usually branches are really hard to test because you have to satisfy all the conditions and stuff. This set timeout hasn't been tested, or the output of the set timeout hasn't been tested yet. We haven't tested. In order to test this, by the way, for this example, you would do expect this.moreMenuConfig.visible to be false, and that would test it. And this one you would do you would set a stub for cdref. I believe cdref is change detector reference, so you would have a stub for this, and this change detector reference put in a Jasmine spy for mark for check, and then you would test to see if that has been called, and that's how you would cover these few lines of code right here. This one, you would just, this one is kind of hard because it's using native element.query selector, and it's kind of a DOM manipulation one, so that's why I didn't test that one. Sometimes these are little cheats that I used. Like this one, I passed in a variable called test. This is just because I didn't want to test any of the actual DOM manipulating stuff. So this one actually calls a submit on the search form. And this is something I feel like should be tested by end-to-end tests instead and not by unit tests. That's why I kind of bypassed this with a test variable. A condition. This is an optional test variable. I know, like, for unit test purists, you should test this, but for me, I prefer this to be tested by end-to-end tests, so that's why I skipped this one. This one should be tested as well. This one's actually pretty easy to test. You just make a describe for key press handler, and you put in event key code 13. Actually, I think this is why it hasn't been tested, because of this search input native element dot value. You have to mock out a search input native element for the DOM object, and then you would put a spy on submit search and test to see if that's been called. This is a similar one. It's the open modal listener, so you would actually have to mock out this one instead. I believe this was mocked out in the test, but yeah, obviously it hasn't been. Oh, it has a subscribe. Okay, so you'd have to call the subscribe here. So there's some more that had to be done here to get this one to go in. So yeah, otherwise this is how you see like what parts of the code you've missed with your unit test. So it's pretty useful. So yeah, that's a code coverage file that's generated. Pretty useful, I think, and you do it with the command ngtest --code coverage. And that's it, guys. If you guys have any questions or comments about this little guide here, I know I went a little bit fast for some people and I kind of rambled a lot, but yeah, let me know if that helped or not. So let me know if this guide helped you or not. That's it, guys. Thanks for watching, and this is my first programming kind of guide. That's why I rambled a lot. Yeah, let me know if you enjoyed it though, and if I should keep doing these kind of programming guides. And that's it. Thanks guys for watching. See you guys next time.